Section 1.6, we start talking about inverse functions. And I want you all to just take a second. We're going to think about the function f of x equals x plus 2. We're going to find f of 3. So that means we put 3 in for x, and so it's 3 plus 2, which is 5. Right, so think about it as the 3 is transformed into a 5. Now what an inverse function does is takes the 5 and transforms it back into a 3. So let's figure out what function would do that. We take a 5 and turn it into a 3. And that's going to be the function x minus 2. So inverse functions are also going to have inverse operations. All right, so I have a couple of examples where we know some information and we can find other information. So if f of 3 is equal to -1, it takes 3 and turns it into a -1. Then we can find f inverse, that's the inverse notation, f to the -1. We can take the -1 and it would take the -1 and turn it back into a 3. Right? And then f inverse of -5 is 2. What do you know about f? So it means that the original function took 2 and turned it into 5. Right? And those are just other functions, just random functions I made up. Okay, so one thing we're going to do today is verify that two functions are inverses. And to do that, we use the composition. So you do f of f inverse of x, and it just, everything kind of simplifies away, and you're just left with x. And you have to do it the other way as well. F inverse of f of x, everything just kind of simplifies away, and you're just left with x. Okay. So on example 3, we're going to find the inverse function informally, and then verify using that rule where you do the compositions. All right, so we have to think about, if we're finding the inverse of f of x equals 8x, we have to think about kind of inverse operations. So the inverse of multiplying is dividing, right? And if you think about it, let's say you put 2 in here. If you put 2 into f of x, you would get 16. So then the inverse should take that 16 and turn it back into a 2. And so if we put 16 here, divided it by 8, it would turn it back into a 2. So it did its function by undoing what the original function did. All right, so to verify this, we're going to do f of f inverse of x. So that means we're going to take the inverse function and put it into f. So we'll take that and put it in for this x. So when I do that, my 8's cancel out, and I'm just left with x. That's what's supposed to happen if they are inverses. All right, and to completely verify it, we have to also do it the other way. So we're going to do f inverse of f of x. So this time, we're going to take f of x and put it into the inverse function. And that is just going to give us x. All right. See right with this one as well. So think about that for a second. Think about what undoes adding 1. Sorry, I told the answer. What does subtracting 1? Undoes subtracting is going to be adding 1. So we'll do f of f inverse of x. So f of x plus 1. We'll take that, x plus 1, and put it into f. And we're just left with x. And then we'll do it the other way as well. So we'll take x minus 1 and put it into that x. And so it simplifies to x and you're done. Okay, example 4 is the same thing. Well, we're given the inverses and we have to show that they are inverses of each other. And these are slightly more complex functions than what we just did, but we're still going to do the same thing. We're going to do f of g of x and simplify it down, and then g of f of x. So we'll start with f of g. So we take g, which is the square root of x minus 1, and we're going to plug it in to the f function. So that means we're going to square it and add 1 to it. Now, I know you guys are really smart, and you're going to know that this is going to end up being x. But when I put this on a test or a quiz, I'm going to look at your work. So if you just do that and then say equals x, you're not going to get credit for it. So you have to follow the order of operations. So what you would do first here is square the square root, and they undo each other, and then bring it down without the square root, and then do the subtraction. All right. If you try to do the subtraction first and then do the square, it's not going to be right. All right, we'll do the other one. We'll take f and we'll put it in for x and g. So that means it's going to be under a square root. Yeah, and then we're going to subtract 1 from it under the root as well. So this one, you're not going to cancel out the square and the square root first. That doesn't do it in that order. This time we would subtract first, and then we would do the square root of x squared and just get x. All right, so don't rush through that. Just follow the order of operations. Okay. Now today we're not finding any super difficult inverses, but we'll do that on the next lesson. But I do need you guys to understand that not every function has an inverse function. So for a function to have an inverse function, it must be 1-to-1, which means every x has one y and every y has one x. So no, y's don't repeat and x's don't repeat for it to be a function. Y's don't repeat for it to be 1-to-1 function. And then what we use to determine if a function is 1-to-1, which means it has an inverse, is we use the horizontal line test. So the vertical line test we use to determine if a graph is a function. The horizontal line test, we determine if the graph is 1-to-1. All right, so we're just going to use what we know about the parent functions to figure this out. In the worksheet, you have the graph drawn. But anyway, on this one, this first one is actually a line. This is a linear function. So you could rewrite it if you wanted to as y equals -1/2 x plus 3/2. So it's going to be a linear equation that has a slope of -1/2 and crosses at 1.5. So that's that. Every linear equation that's not a horizontal or vertical line passes the horizontal line test, is a function. So this one is yes. As long as it's a slanted line, it's going to be a 1-to-1 function. Okay, for B, this is a parabola. I should already throw up some red flags. That's shifted down 3, so it looks like this. So it's going to fail the horizontal line test. So it is not 1-to-1, and it would not have an inverse function. And then this one is absolute value, so it's a V graph that shifted to the left one. All right. So it's also going to fail. Like if I drew a horizontal line, boom, it's going to cross it 2 places. So it fails. This one, I didn't draw the line, but it fails also. So those are both no and no. All right. So your assignment is going to be the front of the worksheet. think that is 1 through 8. Let me check real quick. Nope, it's 1 through 10.